Dear students, now 10th class, chapter 2, polynomials, we are starting now. Chapter 2, polynomials. So, first we will start our discussion with the definition of polynomial, right? So, an expression, definition I am giving for polynomial, an expression of the form P of x is equal a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus 1 plus an. So, an expression of the form P of x is equal this, where here what are a naught, a1, an, these all are real coefficients, where a naught, a1, a2 and so on, an are the coefficients of terms of the respective terms which are real numbers. These are coefficients of the respective terms and these are real numbers. And particularly that a naught should not be 0. The leading coefficient should not be 0. The leading coefficient should not be 0 and n is a positive integer. So, this is the definition. So, this is a polynomial in terms of the variable x. Sometimes you will see polynomial in terms of variable y, in variable z. Variable may be different, but the definition is same. Suppose you are talking about a polynomial in variable y, then you have to write P of y, like that. So, usually polynomial in x is denoted by P of x. Please do remember this. Now, some examples let us see for polynomials. So, P of x is equal x minus pi, P of x is equal root 2x square plus 3 root 2x minus pi root 2, P of x is equal 3 by 2x square x cube minus 5 by 4x square plus 2 by 3x minus 3 by 8, etc. These all are various examples for polynomial. Did you understand? Now, our next discussion point is degree of the polynomial. The highest power of x appearing among the terms in the polynomial is known as degree of the polynomial. Once again I will repeat, see, the highest power of x appearing among the terms in the given polynomial is known as degree of the polynomial. So highest power of x, for example, simply saying highest power of x is called degree of polynomial. Degree of polynomial p of x is denoted by deg of p of x, like this. So in the previous definition, whatever the polynomial which we have taken, okay, a naught x power n plus a1 x power n minus 1 plus so on, that we took, no? There that highest power which is appearing is n. So in that context, degree of p of x is n. In the previous example, whatever p of x is appearing, whatever p of x we have wrote in that polynomial, okay, the degree is n. It is not example, of course, it is definition. So in the from the previous definition, that degree of polynomial p of x is n. Now let us take some particular examples. Suppose take p of x is equal x plus 3x cube minus 5x power 4 plus 6x minus 2x square plus 8, say, for example. Of course, usually polynomial terms of the polynomials are to be kept in order, but here just I wrote in a misorder, but nothing to worry. So now what would be the degree of the polynomial here? What among all the terms, highest power is what? Highest power of x, you are seeing 4. So highest power of x, as you are seeing, 4. So therefore degree of polynomial here it is 4. Degree of p of x is equal 4. Understood? Right. So here I am giving you a table which gives various types of polynomials and an example in general form, and one more, we are particular example also we will take one. So type of polynomial, next standard form, let us take first here degree of the polynomial. Next standard form, a particular example. We can also have a particular example. So this table gives you clear information, okay, about various types of polynomials, their degrees and the standard form, and a good particular example if you take, you can easily compare. So now type of polynomial is constant polynomial. Constant polynomial. I don't write that polynomial again. Here type of polynomial. So it's a constant polynomial. You can add that word. Constant polynomial degree is 0. Constant polynomial degree is 0. Its standard form is p of x is equal to c. And a particular example for constant polynomial is p of x is equal to 10. Understood? Next, this standard form, it is a particular example. Next type is linear polynomial. Next type is linear polynomial. So degree of linear polynomial is 1. Standard form of a linear polynomial is p of x is equal to ax plus b, where a is not equal to 0. And a particular example for linear polynomial is p of x is equal to 2x plus 5. One particular example only we are taking. Next, quadratic polynomial. Degree of quadratic polynomial is 2. Standard form of quadratic polynomial is ax square plus bx plus c, where a is not equal to 0. A particular example for quadratic polynomial is 3x square minus 4x plus 5. Are you following? Coming to next, cubic polynomial. Degree is 3. Standard form is ax cube plus bx square plus cx plus d. And particular example, 5x cube minus 3x square plus 4x plus 7. Here leading coefficient is not 0. That you have to always, you should make that note. Next, biquadratic polynomial. Biquadratic polynomial. It's a degree 4 and its standard form is ax power 4 plus bx cube plus cx square plus dx plus e, where a is not equal to 0. And the particular example is p of x is equal 3x power 4 minus 5x cube plus 6x square minus 7x plus 10, etc. You can take. So this table, I think, gave you adequate information. Now coming to our next point of discussion is 0 of a polynomial. Before going to 0 of polynomial, we have to discuss one more point, value of a polynomial. So now, value of a polynomial at a given point. This is our next point of discussion. Now I will give you definition. See, let the polynomial be p of x. Definition this is. Let the polynomial be p of x. and a given point. A point means here what I mean to say, a point means a real number. Point means a real number. That's what I mean by point. And a given point is, say, C, where C is a real number. Then P of C is known as, that means where X has to be replaced with C throughout the polynomial. Throughout the given polynomial, if X is replaced with C, what you get is denoted by P of C. So then P of C is known as the value of the polynomial P of X at X is equal to C. So the value of the polynomial P of X at X is equal to C is denoted by P of C. So I'll give example so that you will understand very well. So example, suppose say P of X is equal x cube minus 3x square plus 4x plus 5. So this is P of X. Next, then find the value of the polynomial find the value of P of X at X is equal to 2. Say this is a question. Now question as well as example for this definition. So solution is, given polynomial P of X is equal to x cube minus 3x square plus 4x plus 5. This is P of X. Now we need to find the value of P of X at X is equal to 2. To find value of P of X at X is equal to 2, that is to find value of polynomial P of X at X is equal to 2 means P of 2. So we need to find P of 2. So P of 2, how you can get? You have to replace X everywhere with 2. So 2 cube minus 3 into 2 square plus 4 into 2 plus 5. So this is equal to 8 minus 3 into 4 plus 8 plus 5. 8 minus 12 plus 8 plus 5. So 8 plus 8, 16, 16 plus 5, 21. 21 minus 12. 21 minus 12 is obviously 9. So P of 2 is equal 9. So the value of this polynomial at a given point 2 is 9. Understood? Now our next definition is 0 of the polynomial. So 0 of the polynomial. This is most important definition. It plays major role in the polynomials chapter. 0 of the polynomial. If p of x is a given polynomial and x is equal to at x is equal to c, if p of x is equal to 0, then that x is equal to c is known as the 0 of the polynomial p of x. Understood? I will write the definition. See, if a polynomial p of x is such that if a polynomial p of x is such that the value of p of x at x is equal to c is 0, in other words, p of c is equal to 0, then x is equal to c is known as the 0 of the polynomial f of x. Or p of x. So once you see the definition, Babu, for 0 of polynomial, if a polynomial p of x is such that the value of p of x at x is equal to c is 0. Value of p of x at x is equal to c means, in other words, it is p of c. That is, p of c is 0. If p of c is 0, then x is equal to c is known as the 0 of the polynomial p of x. Understood? Now, for example, verify that x is equal to minus 2 is 0 of p of x is equal, verify whether x is equal to minus 2 is 0 of p of x is equal 3x plus 5. Verify whether x is equal minus 2 is 0 of p of x is equal 3x plus 5. How you will verify? You have to find p of minus 2. So p of minus 2 gives you 3 into minus 2 plus 5, which is equal minus 6 plus 5, which is minus 1. The value of the polynomial p of x at x is equal minus 2, which is p of minus 2, you got as minus 1, which is not equal to 0. Understood? Therefore, x is equal minus 2 is not the 0 of the polynomial. P of x. Understood? Now let us go for another example. Verify example 2. Verify whether x is equal minus 2 by 3 is the 0 of the polynomial p of x is equal 3x plus 2. This is the question. So you have to find out the value of the polynomial p of x at x is equal minus 2 by 3. That means you have to find out p of minus 2 by 3. So take p of x is 3x plus 2. Find out p of minus 2 by 3, which is equal to 3 into minus 2 by 3 plus 2. Then 3 gets cancelled, minus 2 plus 2, which is 0. So p of minus 2 by 3 is 0. What does it mean? It means that x is equal minus 2 by 3 is the 0 of p of x. Understood? So now we have discussed what is 0 of a polynomial. Now what we are going to discuss in the next is the geometrical meaning of 0 of a linear polynomial. See here, our heading is geometrical meaning. We are trying to find out the geometrical meaning of 0 of a polynomial. Linear polynomial, that too here. We are going to find out the geometrical meaning of the 0 of a linear polynomial. So now let us see with an example. Let us see p of x is equal x square minus 5x, so linear polynomial we are supposed to take. So p of x is equal to say x plus 2. It is a linear polynomial. P of x is equal to x plus 2. So now find out the 0 of the polynomial. Here the 0 of the polynomial is clearly x is equal minus 2, because if you replace x with minus 2 then it would be equal to 0. That is why x is equal minus 2 is the 0 of the polynomial. So for this 0 of the polynomial we are going to see the geometrical meaning. So now let us take the graph of this polynomial. X, y means p of x here. Suppose x is 0. Suppose if you replace x is 0, what would be y? Y means p of x. It is 2. Are you following? Now, suppose if you take x is minus 2, y is 0. Our polynomial is 0. If x is 1, our y is 3. If x is 2, our y is 4. But that's it. So I took some points which satisfy the equation y is equal x plus 2. Now let us take Cartesian plane. Of course this is rough diagram only. Here our intention not to draw the exact graph without a single error. Here our intention is to see what the geometrical meaning of 0 of polynomial. So now you see here 0, which is origin, it is x-axis, this is y-axis. Now take some points, 1, 2, 3, 4, 5, etc. The scale on x-axis is 1 unit is equal 1 unit is equal 1 centimeter is equal 1 unit. So here minus 1, the same scale we are going, even this side. Everywhere you are going to take the same scale. 1 centimeter is equal 1 unit. So you go like this. Here also Now, when x is 0, y is 2. So that point will be here. X is 0, y is 2. That point is here. When x is minus 2, y is 0. That point would be here. When x is minus 2, y is 0. When x is 1, y is 3. So the point would be here. When x is 1, y is 3. And when x is 2, y is 4. So now you join all these points. Now you can see easily a straight line. So this is a straight line, y is equal x plus 2. So this is a straight line, y is equal x plus 2. So now the geometrical meaning of 0 polynomial, now you can see it is the x coordinate of the point where the line is meeting x axis. Did you understand? So this is the 0 of the polynomial, no? Minus 2. So the geometrical meaning of 0 of a linear polynomial is, it is the abscissa of the point where the line meets the x-axis. So that is the conclusion. Understood? So I am not writing to save some time, just I will repeat once, you please see here. The geometrical meaning of the 0 of a linear polynomial is the abscissa means first coordinate, x coordinate. The abscissa of the point where the line meets the x-axis. So the line where it is meeting x-axis, at that point x coordinate would be the 0 of the polynomial. Understood? Now we are going to see the zeros of the quadratic polynomial, geometrical meaning of the zeros of a quadratic polynomial. So geometrical meaning of zeros of a quadratic polynomial. So here you see, let us take the polynomial p of x is equal x square minus 5x plus 6. Now let us find out the zeros of this polynomial. So for zeros of polynomial, p of x, p of x is equal to 0, then x square minus 5x plus 6 is equal to 0. So if you factorize by splitting the middle term, square minus 2x minus 3x plus 6 is equal to 0. So if you take x common, x minus 2, taking minus 3 common, x minus 2 is equal to 0. So taking x minus 2 common on the whole, x minus 3 is equal to 0. So x minus 2 is equal to 0 or x minus 3 is equal to 0, plus x is equal to 2 or x is equal to 3. Therefore, the zeros of given polynomial are 2, 3. Now I am interested in finding the geometrical meaning of the zeros of a quadratic polynomial. So for that, you have to draw the graph of this quadratic polynomial. So I am not drawing exact graph, only rough diagram I am taking. So only rough diagram. So if you just only it is rough diagram, Babu, please don't take this diagram very seriously, okay? Just I would like to make you understand the geometrical meaning of zeros of a quadratic polynomial. So just I am taking a rough diagram. To take the rough diagram, the diagram will come like this. Like this it goes. Okay. So here like this it goes. So here the graph is meeting x-axis at the points 2 and 3. So now if you draw the series diagram also, it will come like this only. Okay, you draw, you can please take a graph sheet and you draw, take some points, that graph will come. Of course, roughly in this shape only. Okay. So now, here is the geometrical meaning of zeros of a quadratic polynomial is these zeros are the abscissae of the points where the graph meets the x-axis. This is the point you have to understand. Only to make you understand, I have drawn this diagram. So here, understanding geometrical meaning is more important, okay, than drawing the exact graph. Okay, please try to understand. The weightage is for understanding the geometrical meaning of the zeros of quadratic polynomial, but not giving so importance to drawing the exact graph. Okay, so that is why I have given a little less preference of drawing the diagram, and I am giving more preference to make you understand the geometrical meaning. So the geometrical meaning of the zeros of a quadratic polynomial is they are the abscissae of the points where the graph meets the x-axis. Graph meets the x-axis. See here, this graph is meeting x-axis at the point, okay, 2, 0 and 3, 0. So at these points, the abscissae are 2 and 3. These abscissae are the zeros of the quadratic polynomial. Understood? Sorry.